Okay, Module 5, last stretch. This is the last lecture you will see. So let's get going and get it over with. So from last week, you learned how to find the slope with the formula, which was m is y2 minus y1 x2 over x1. You learn about the intercept. You learn about the slope-intercept form, which looks like this. Okay. M stands for the slope. B is the y-intercept. Okay. And then from last week as well, you're able to figure out the equation given 2 points. Something like, say, this. Or if I give you a slope, and then the point, you should be able to give me the equation for either one of these. So for this week, we're going to experiment on these skills and then graph inequalities. It's almost like 99% the same as graphing equations, and there are a few minor modifications which I'll show it to you in a little bit. So in inequalities, you should know these things. This is an equal sign. This is less than. This is greater than. Okay. If there's a bar underneath, this means less than or equal to. And if it's the other way around, this is greater or equal to. Okay. So, if you see a question like, now you know that's an inequality. So how do you graph inequalities? If you look at page 4 at the top, there are steps there. It's going to be very similar to graphing equations. But number one, graph the inequality just like you would if there were an equal sign instead of an inequality. Just go back to page 2. But we'll deal with this inequality sign. So the graph will look different if this is, say, greater than or equal to, or just plain greater. If that's the case, the line will be dashed lines. It'll be the solid lines. If it's a simple less than and greater than sign, then the line will be dashed lines. So let me show you what I mean by that in a little bit. And number 3 is, instead of just a simple graph, in inequality, you have to shade one side or the other one. And then I'll show you what that means as well too. So let's say you want to graph this. Okay. So just like equations, I'm going to pick some random 3 points. So say I pick x, y, always pick a 0. Say I'll do 2 here and then -1. So -1 times 4 is -4 minus 3 is -7. 0 minus 3 is -3. 2 times 4 is 8 minus 3 is 5. So let's plot this. I gotta make a bigger plot here. So -1 and then -7. 1, 2, 3, 4, 5, 6, 7. 0 and negative 3, and 2 and 5. 1, 2, 3, 4, 5. Somewhere there. I see it's a straight line. I don't draw anything quite yet. Since this is a greater than or equal to sign, the line will be solid. If this was just a greater than sign, then the line will be dashed. So since it's greater than or equal to, there's an equal bar down there, so I'm going to draw a line. Okay, instead of a dashed line. So that the next question is, I'm going to either have to shade the above the graph or below the graph. What does that mean? Okay. If I take you back a little bit, back in time a little bit, you saw something like this. Say x is less than or equal to 3. If that's the case, you remember that it's going to be a closed circle, and then you drew a line or arrow pointing this way because it's less than. We have something similar in the graph. Instead of the arrow, we're going to shade, because there are two variables, and then that means it's two-dimensional. So now the question is, which side do you shade, above or below the graph? There are a couple of ways to do that. Figure that out. A lot harder than what I'm going to show it to you. So the easiest, so I'm going to show you the easiest way. The easiest way to check is to check the center, this point, which is 0, 0. So y less greater than or equal to 4x minus 3. I'm going to plug in that 0 here. 0 is greater than equal to negative 3. Now the question, so I plug in the 0 here because it's 0, I'm checking the 0. 4 times 0 is 0, so then this is left over. Now you look at this inequality and ask yourself, is 0 greater than or equal to negative 3? Is that true or false? Since in this case it's true, 0 is greater than negative 3, and then the center is to the above of the graph, that's the region I shade. Say if this was something like this, if it ends up being like this, for example, that means this side is false. This point makes this side false. So if that's the case, you shade this side. So that's how you graph inequalities. You gotta check two things. Is it gonna be a bar or a dashed line? Or sorry, straight line or dashed line? And then check 0, 0, and make sure you shade the right side, the correct side, above the line or below the line. It's on page 4. Okay. So now let's move on to the system in monomials. We have a thing called a systems of equation. What's that mean? Well, basically, if you have a pair of two equations, together it's called a system. So that's why it's called a system of equations. So I'm going to solve this system. Solve the system by graphing. So the solution to this system will be a point, some kind of point, x and y, and it's going to be an intersection. For the system, our solution could be either intersection, parallel lines, or overlapping each other. So we're going to only focus on the scenario where the graphs intersect, and whatever the intersection is, that's considered to be the solution. So that's what we're going to find right now. So let's graph this. Okay, so let's graph negative 2x plus 6. X and then y. I'm going to pick 0. Let's pick negative 1 and then 2. So negative 1 times 2, or negative 1 times negative 2, that's 3 plus 6, that's 9. With the 0, that'll be 6. And then 2 times negative 2, that's negative 4 plus 6, so that's 2. Right? Negative 2. Negative 2. Yep. Okay. So instead of doing negative 1 and 9, I'm going to do 0, 6, and 2 and 2. 0 and 6, which is like over here. 2 and 2, somewhere like there. Okay. Oops, should be crossing here. And I'll do this in green, x and the y. So since it's a fraction, I want to get rid of the fraction. So I'm going to pick, say, negative 4, 0, and say 8. Okay. So negative 4, that means negative. It's going to be negative 3 plus negative 3 plus 1. So that's negative 2. Because the 4's cancel off, so that means negative 3 plus 1, negative 2. 0, that will cancel off at 1. If I plug in the 8, 8 divided by 4 is 2, so 2 times 3 is negative 6, plus 1, negative 2. Oh yeah, this is not correct. Negative 4, that makes it positive, so 3 plus 1 is 4. Negative 4, so replace yeah, and then 8 negative. So that would be 5. I should probably know this by now. Yeah. So negative 4 and then 4. 1, 2, 3, 4. Okay. 0 and then 1. And then 8 and 5, negative 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Okay. So where is your intersection point? If you did this on the graphing paper, you see that this is going to be 4 and then negative 2, kind of there. So I recommend you do this in the graphing paper. So if you did this on the graphing paper, you find the intersection to be the coordinates 4 and then negative 2, and that's the solution to this system. You can solve this by graphing and finding the intersection. Another method you can do to solve an equation or system of equation is what we call substitution. And for the substitution method, what you do is you're going to substitute one equation into the other one. And it really is easier than it sounds. What you want to do is, for substitution, look for a pattern that's like x equal to something something, or y is equal to something something. That's the key. Here's what I mean. So say you want to solve 3x plus 2y is 11. Negative x plus y is 3. I probably want to use a substitution method for this because for one, it's hard to graph this. It's a little more complicated than just simple graphing. And then two, I can identify, say, x equal to something something or y is equal to something something. Here's a candidate, y by itself. So how do you isolate the y by itself? Well, let's get rid of this negative x by adding x. So if you do that, second equation becomes y is equal to x plus 3. Since I want to identify or isolate just x is equal to something something or y equal to something something, what I do is look where the coefficient, the number in front of the variable, to be just a 1. In this case right here. So I want to isolate that, so let's get rid of the negative x by adding x to both sides. So this becomes this. So now we know that the y is equal to x plus 3. So what I'm going to do right now is I'm going to substitute the y with x plus 3 in the other equation. So I'm going to plug this in into where that is. So let me do that and show you what that becomes. So how do you substitute it? Well, rewrite the other equation, 3x plus 2, but then put the parentheses where the y is, plus is equal to 11. Substitute what? Y is equal to x plus 3, so let's put x plus 3 there. So what's this equation? This equation, two variables, became a problem of one equation. And that's the problem you've been doing since week 1, or maybe week 2. So we converted two variable equation into a single variable equation, which you know how to solve. So let's do that. It's going to be 3x plus 2x plus 6 is 11. First step, simplify. So let's add these two together, 5x. Okay, I simplified it. I'm going to isolate just the x. So subtract 6. So this becomes 5x, is log minus 6 is 5. And then I want to get to x equal to something something, so I'm going to divide this by 5. So x is 1. We're not quite done yet because we need the coordinates, meaning that I need the x value and then the y value. So now I know x is 1. Where do you substitute this back into? Where do you use this in order to solve for y? Here's the easy part. Right here. We already know that y is equal to x plus 3. So that, and then if x is 1, what's y is going to be? 1 plus 3, which is 4. So to solve this original problem, the final answer is 1, 4. That's how you do substitution problems. Okay. If you're a little bit hazy, you might want to rewind and then rewatch what I just did. It's not all that bad once you get used to it. So what kind of question can I ask? Your favorite question, which is on page 6. Word problem. What are the length and the width of the rectangle below? The length is 6 centimeters longer than the width, and the perimeter, the outside dimension, is 40 centimeters total. So let me draw that. Width, length. So if you go all the way around, they add up to 40 meters, or 40 centimeters, so W plus L plus W plus L is 40. Because it's W over here and it's over there. So what I did was the other problem says the length is 6 centimeters longer than the width. So that means width plus 6. So the length is 6 centimeters longer than the width. So 6 plus W is L. What does that look like? Well, that looks like a system of equations, which happen to use W and L as variables, but there are 2 variables, 2 unknowns, system equation. All right. Would you graph this or use substitution? Well, if we can easily graph it, go ahead and graph it, but can you easily graph these 2 things? Not really, so the only choice you got is substitution, so let's do substitution. And I'm going to use substitution because L is W plus 6. L, one of the variables, is isolated by itself, so why not take advantage of that and then use substitution to solve this problem? All right, so this will become 2W plus 2L is 40. L is W plus 6. So I'm going to substitute this part into here. So that equation becomes 2W plus 2, big parentheses, plus equals to 40. And then W plus 6 here. So then this is 2W plus 2W plus 12 is 40. Add them up, 4W plus 12 is 40. Subtract 12, 4W is, what is that? 28. Divided by 4 on both sides. W is 7 centimeter. Okay. So now we know the width is 7 centimeters. So what will be the length? Well, going back to this equation right here, L is 7 plus 6, which is 13. So let's do a quick check to see if the answers are correct. Okay, so this would be 13 here, 6 here, 13 here, 6 here. Oops, not 6, 7. I'm just looking at this. So 13 plus 7 plus 13 plus 7, if you do the math, they do add up to 40 centimeters, so these are the right answers. Okay. So now you know how to do a word problem of the system equations. All right. So the last part you're going to learn is monomials. In week 1, you learned that the term is a combination of a coefficient, a variable, and or exponent. And then terms can be separated by addition or subtraction. So in the expression like this, you know there are 3 terms, here, here, here. And you cannot simplify it any further than that because the variable, the powers are different. This one doesn't have a variable, so that's all there is. If you recall, we learned the term like terms. Like terms have 2 criteria. One is that it has to be the same variable. And then the second criteria is that the variable has to be the same power. So for example, if I ask you to simplify this kind of expression, what you do is basically look for like terms. So the first thing is you look at the power, or the variable, but only these 2 are like terms in terms of the power of x to the second power. And then these two, double line, are the like terms themselves because it's to the x to the 1 power, the one you don't see. So I'm going to combine these two. 8 minus 2, that's 6x squared. 3x plus 9x, you add the coefficients, so that's 12x. And numbers are themselves by like terms, and I don't see any other number, so minus 2. That's your final answer. The monomials, there's another name for term, which is the monomial. And mono means one. So, one term. And it could be anything like 2t, negative 4xy, x to the third, y to the second, 5, or even the fractions, 3 over 2, x to the 5. So these are all monomials. The expression containing any additions or subtraction, divisions of the variable, they're not considered monomials. So these are the monomials, but let's say if it's 2t minus 4xy or something like that. Now it's no longer a monomial. Okay. Another thing you should know is degree of monomial. It's essentially the sum of all the exponents of the variables in that one monomial. It's a double one. Okay. So for example, 7x, y to the third, z to the 5. What's the degree of monomial? Well, you add the power. So 5 plus 3, that's 8. But the degree is not an 8 because the x has a power, which is 1. Don't forget the invisible 1. So the power or degree of this monomial is 5 plus 3 plus 1, 9. So there are a few other rules you need to know in terms of operating on monomials. For example, multiplying the two numbers. So I'm going to use a variable to show you what I mean. If you're multiplying two variables that are the same, but different powers, or the exponents, the rule says you just simply add them up. It helps if I give you the right answer, right rule. So for example, if we see something like a to the third times a to the second, you just simply add them up. 3 plus 2, 5. So these are equivalent to each other. Or you might see more complicated ones, something like negative 4, x to the 7, y to the third, 5x to the second, y. Have you heard of a divide and conquer kind of thing? So for this problem, we're going to do separately the number, the one variable, and then a different variable. So in this case, I'm going to look at negative 4 and then the 5. Multiply these together, that's negative 20. X to the 7th power and then x to the 2nd power. So 7th power and then 2nd power. Using this rule, you then add them up. 9. And for the y, 3 plus invisible 1, so 4th power. Okay. So that's how you do that kind of problem. All right. How about dividing monomials on page 8? If you're dividing the same variable, but different power, or the exponents, all you do is subtract them. So if I have something like x to the 5, x to the 2, 5 minus 2, it's always top number minus the second number, or the bottom number, so it's going to be x to the 3. So let's use this rule to figure out this. So again, we do 1 by 1. So 3 over 6. So on your calculator, press 3 ABC is 6. What do you get? You get 1/2. So what's 1/2? X to the 5th power and x to the 7th power. So 5 minus 7. So that'll be x to the -2. Y to the 10th power and y to the 9th power. So that's going to be y to the 1 power, which I don't write. And then what happens to this x to the 2nd power is that if it's a negative number, it switches sides. So the real answer to this is 2x squared and then y. I get rid of the 1 here because the y is there, so it's redundant to write 1y. So if it's a negative number, why does it go to the bottom? Which brings us to the last rule. If you have a negative exponent, the rule is you drop it to the bottom of the fraction. So say if you have something like 4 to the -3 power, what happens is that this becomes 1 over 4 to the 3rd power. Okay. So let's do another problem. 3x to the -5 power, y to the 3 power, divided by z to the -7 power. So what happens here? Well, 3 stays on the top, there's nothing else to combine it with. The x, since it's a negative power, it goes to the bottom. How about the y? Well, y stays up there because it's a positive power, so y to the 3rd. What do you suppose, what happens to the z? Z has a negative power, but then it's at the bottom. If you remember, I mentioned that if it's a negative power, all it does is switches sides, top and the bottom. So if it's in the bottom and it's a negative power, what happens is that it becomes a positive and then jumps to the top. So z to the 7th power. Okay. Don't get confused by that. Alrighty, your class is done. So then let's study for the final exam.